Hello everybody and welcome to another Unity game development video. It's been about a month or so since I made the last one. I've been posting a few short videos showing off just aspects of what I've been working on without any kind of explanation, just kind of silent videos showing off like the health bar moving and stuff like that. But I thought I would make kind of a devlog video and explain what I've been working on, and specifically pertaining to the last video I posted with the health and how that's affected and how I've set that up in Unity. And so I thought I would just go into it and show you what's going on. So I'm just going to press play, and then I'm going to get into the game, and you'll see in the bottom left I have the game view, and the top left I have the scene view. The main difference between the last thing I worked on and this one is I've converted the entire project from the HD render pipeline to the universal render pipeline. And a huge reason for that is there's a lot of things that I plan on implementing into my game that are not supported in the HD render pipeline. When I had initially set up my project with it, I had just assumed that mostly everything was supported, and it was kind of just a resources related setup where it was just, if you want to use the HD render pipeline, there's going to be a lot of particle effects and a lot of post-processing and kind of underlying things that would just create issues for the game to run on lower end hardware and like phones and stuff like that. So apparently that's not what's going on. Apparently the HD render pipeline is specifically for currently like commercial use. Like there's graphical things you could do for like movies and stuff like that. And I guess you could use it for games, but you're going to run into a few snags with very useful items and objects and just features like camera stacking, forward rendering, and stuff like that isn't super supported with the HD render pipeline. So I switched over to the universal render pipeline. And immediately after getting in, I do have two separate camera renders in this, so I'm only getting around 400 to 500 frames per second. But with just the base project I had working on and moving it over from the HD render pipeline to the universal render pipeline, I went from getting around 200 frames per second to about 1,500. So there's a significant performance boost when working on a lower graphically fidelity projects with something like the universal render pipeline. So basically I've just transferred this over to the new pipeline, and I've been working on a few things, and the only reason I really noticed that I needed that is I needed some kind of forward render or camera stacking, or like a what is it called when it clears the depth buffer for cameras, and that wasn't really something that was available in the HD render pipeline. So I had to switch over to universal, and turns out there's also a lot of other features that aren't really possible in HD render pipeline. So what I've done is I switched over to this one, and so far the only new thing I've implemented is this health bar, and I wanted to talk to you about that. But other than that, I have made a lot of like efficiency changes. I've changed a lot of things where it's not frame rate dependent anymore. Still, there's a few things that are currently frame rate dependent, like mouse sensitivity. There's input like functions and stuff like that I have to switch over. But so far it's going pretty well with just making that kind of stuff work. But I've got this new health bar, and you can see up in the scene view, the health bar is in 3D space. It is not actually being rendered onto the UI. What is it called? Canvas, I think they call it, like a UI canvas. It's actually a 3D object in the screen, but it's currently being rendered onto an orthographic, I believe. Yeah, an orthographic camera that's facing directly at it. And as opposed to a perspective camera, it's just gonna show everything at generally the same scale and distance. So what I can do is I can take an object like this, and I can put other objects directly behind it that are the same scale, and they'll fully obscure each other. And what's going on here is I have a background color here, so that would be the health bar when it's completely empty. This is the damage bar, so this is kind of, you might be familiar with this kind of system. If I press the one key that I have here set to debug for the health bar, if I press that, I'll lose some health. And then you'll see that it slowly matches the scale of the normal health bar. You can see that up in the scene view as well. So basically, I'll explain this stuff in the code, but what's happening is I have empty objects here that I'm calling scalars, and I have like a 3D object here, which is just a plane with a simple color added to it. And if this scale, if I go to the 2D view, is set to the far corner of the object right here, as that scales in size, its child objects will also scale. So if I have it scaling in one axis, then I can scale this entire health bar to 0. So if I go back into the game and I use the debug tools to lower the health, you can see it working until it is 0. And as you can see, I have it set up where the damage bar, the dark red one, scales where it increases in scaling speed the more damage there is. So the greater the difference between the health bar size and the damage bar size, the faster it will go. So as it reaches the matching the health bar size, it'll decrease in speed. And if I go into the right here into the player manager, I can show you that stuff. We have HP, we have a static HP value that can be accessed from other scripts and other objects, and that's basically so if the player is hit by an enemy or a hazard of some sort, we can actually just call that function and we can inflict damage on the player from the enemy. We have a damage cooldown so that when the player gets hit, they're not constantly losing health. There will be a small amount of time before they can get hit again. Damage timer is just the value that is being iterated on by time to reach a damage cooldown, so we can determine when the player can be hit. We have health statuses, which is an enumerator. We have death or dead, near death, half health, almost full, full health, over health. And generally, I don't know if, I mean, these are definitely not finalized, but I was just getting a kind of general sense of what this would look like. And the main thing these are going to dictate is potentially like the player portrait of the character will be up in the corner, and also just the animations that are being used on the actual characters. So, you know, very common things in games is when you're near death, the character will be panting or kind of slunched over or something like that. So that'll make it a lot easier to handle that in the future. Health status requirements. So the requirement for dead is 0 health, near death is 1, and this should scale with a any amount of health points you want to give. So we could have the max health value of maybe 100, and we would just simply divide that max scale. We would divide the amount of health points by the amount of scaled items and then multiply it by the value that it's within. So if there was 100 health points and we wanted the second value in this kind of scaling function, we would divide it by the amount of scale points and then the value itself. So there's 1, 2, 3, 4, 5. So we do 100 divided by 5 times 2. So what is that? 40. So you'd have to have at least 40 health to reach the half health section. And I guess that doesn't make sense. You would have to have 40 health to reach halfway through, because we're not actually including the 0 with the death. So If that makes any sense to you, hopefully it does. I'm going to move on from there. We can go down. We have the current health, the health bar scaler, damage scaler, and this stuff I will explain when we get to the actual function, so I'm just going to keep going. At start, we're setting the scale of the health bar to the local scale of the health bar object. So this health bar scale is actually a float, and we're grabbing the local scale, the x value of that object. So the health bar scale is equal to that scale that we just grabbed, so we're just setting the initial size so we can change that as we go. The damage bar scale is doing the exact same thing, but instead of grabbing it from the object, we're skipping a step and just grabbing it from the value we've already attained from the health bar scale, since they're going to be directly affecting each other. The health points are set to the maximum health, and then health equals current health status, so we're basically just determining these initial health values. Now if I go down and we go here, if the health status is dead, or if health points are less or equal to 0, then control over the player is denied. If we go down some more, I have a debug setup here that was just affecting the health width. This is just a setup here, so when I press the 1 key on the numbers overhead, we can just affect the health by 1, so I can test out the health bar. We're updating the health bar, we're updating the damage bar, and the damage bar timer, which you'll see down below. So, and this is this update damage bar is only running if update db, which is a bool, is true. So if it says to update the damage bar, we're going to update the damage bar. And what's determining whether or not that is true is the damage bar timer. So every time the player is hit, a small timer will start, and then once that reaches a certain amount of time, the damage bar timer will the damage bar scale will try to match the health bar scale. So we'll go down, affect health. So basically this function is a static function, so we can call it from an enemy. Let's say an enemy hits our player. That enemy will have a damage value connected to either an attack or just the player, the enemy itself. It'll feed that damage value into this affect health function. So we can just call player manager.affect health and then the value from the enemy, and then we could feed that magnitude in, and then that'll affect the player. So if the damage timer, so determining if the player can even be hit right now, is equal to 0, and health points are greater than 0. So if the player can be hit and the player isn't dead already, then we're going to affect the health points. If the health points plus the magnitude is less than 0, then health points are just going to be 0. So the reason we're doing that is we don't want to affect the health in such a way that is going to become less than 0, because it's kind of pointless. So let's say we have 3 health left and the attack does 5 damage. We're not going to bring the health to -2 and then immediately switch it to 0. We're going to find out how much health there is to bring it to 0, and we're just going to use that instead of using the initial magnitude. So we're not even going to use that, actually. I was just thinking of a more complicated way to do it. We don't have to use the magnitude at all anymore, because we're just going to find out if it goes past 0, and if it does, we're just going to set it at 0. In my head just now, I was thinking we'll use the magnitude to find out what the difference between the current health and 0 is, and we'll just subtract that. But that's pointless because we don't need to do that. We know that if the magnitude affects it to the point where it's below 0, we just wanted to set it to 0. If it doesn't bring it below 0, then we are just going to add on the magnitude. And the reason we're adding the magnitude is then we could affect health in a positive way. We can heal the player when they do get pickups and stuff like that, so we don't need superfluous functions there. So if we pick up a health item, and that health item is coded to have a affected health magnitude of like 1, we can call player manager.affect health 1, and it'll give 1 health. If we wanted to damage a player, we would call player manager.affect health -1. So then the damage timer is affected. the damage bar timer is set to the damage bar cooldown. And since that isn't a static function, it has to be using the instance of the object. And we're grabbing the instance in the player manager up here. So we have a player manager object somewhere. And that is the instance. If the instance is empty, then we're going to grab this, object. And then we're going to set it as the instance. So when we have a player manager and the game is trying to create a new player manager or a new player object every time we load a new scene, it'll destroy that newly created object and just use the original. So that way we can save the position and any associated values with this player as we enter and load new scenes. Let's see. We did the effect health. Damage check is just handling the damage timer. Let's see. Health status is determining if the player is dead, near death, half health, this kind of stuff. So it's just cross-referencing the health points, the health status requirements with the associated health statuses. Update health bar. So this is where we actually go over the scale of the health bar. So current health bar scale equals health bar scale divided by HP cap times health. So this section really isn't complicated at all. If you've ever calculated the kind of percentage of something without, multiplying it by a decimal that you kind of infer from, the scale of the problem, you've seen something like this before. So you have the health bar scale divided by the HP cap times the health. So basically what we're doing is we're taking the health scale. Let's say that the health bar object, and this is much larger than it actually is 100 units across. That's the X scale of the health bar object. We're dividing by the health cap, which say the health cap is 50. The max health we can have is 50. So 100 divided by 50 is 2. And how much of that health do we have? Let's say we have 25 health out of 50. So we're taking 2 times 25, which is the health, and I guess that was a bad example because we end up back with 50, so that's 50%. So the health bar scale knows to be at 50%. Kind of gave an awful example there because we have kind of reoccurring values with that example, so it's not exactly the most intuitive thing to imagine in an explanation, but hopefully you got what I was trying to say. And then immediately after we determine that scale, the health bar scalar, the empty object that the health bar is in, is given a new scale, and it's just using that health bar scale there. Now we're updating the damage bar. Damage bar is the dark red section on this thing right here. So if we get rid of the scalar for a second, we have the damage bar beneath it. So if the damage bar scale is not equal to the health bar scale, minus just a small fraction of its size, so that we don't have to have it equal the exact value, which Unity can be a little finicky when trying to reach the exact value of something like that. Especially when you're iterating on it with like a very specific scaled unit. Like instead of adding time to delta time, you decide you want to add 1 every fixed update instead of time to delta time, then you're definitely going to possibly overshoot it or end up before it. And yes, I realize I said definitely, probably, shut up. So what is going to happen is we have a graph placer here. The graph placer is equal to the size of the damage bar minus the size of the health bar divided by the scale of the damage bar again. So that's very similar to what we're working on up here, but kind of in reverse. So this graph placer object is used to evaluate this damage scale graph. So if I go in here and I go to the inspector and I look at the player manager, where is it? Player manager, and here is the damage bar scale. we have this object here. So we have this graph placer. The reason we're using the scale object here and we're dividing it by it at the end is if we take this current scale minus the health bar scale, we're getting a percentage, kind of. But what we're actually doing is we're getting a value between 0 and 1. I described a similar thing in my telekinesis push video. I don't know. It's easy for me to understand, but it's hard for me to kind of explain. I guess you either get it or you don't. I think I explained a lot better in my telekinesis video, so just go to, I think, the last game dev video I posted, or whatever the last numbered devlog is that I posted. And then you're getting a value between 0 and 1, and you can use that value to evaluate a graph. So basically what we're doing here is we're just getting that distance between the scale of the health bar and the damage bar, and that's determining the speed of the transition from the damage bar to the size of the health bar. So as we get closer to the size of the health bar, it should slow down. If there's a huge gap between the size of the health bar and the damage bar, it'll speed up. And this damage bar timer is just determining whether or not the bool update damage bar is true. If it's false, it won't update. If it's true, it will update, and then it'll start scaling that object, like I told you earlier. So that is about it. Hopefully that was kind of a not a long-winded explanation. Hopefully you got what I was trying to say. So we have this nice little health bar here, and it scales like that. And as long as I keep adding damage, it'll keep scaling. But when I do add damage, it waits for that timer to go down before it updates. And I think it looks really nice. Hopefully you can discern what I was trying to say, if this is something that you're trying to do for your game. And I kind of just wanted to show it off. So thank you for watching the video, and I hope you see you in the next one. Hopefully it won't take me so long to get around to making one. I just got promoted at a full-time job, so I don't exactly have all the time in the world to make videos. Any time I do have, I'm probably spending working on my game. But thank you for checking it out, and I will see you in the next video.